This is a tutorial for approximation. Let's start. And you can see the calculator here, so we can use calculator for this tutorial. And transform foreign fractions into decimal numbers. Correct to 4 significant figures and 2 decimal places. So in a situation like this, just use a calculator. 5 divided by 7. And for 4 significant figures, so I'm taking the 4 leftmost figures. 0 is not included because it does not carry any values. It is a placeholder. And then 7, 1, 4. Okay, for last digits or figures, be careful that when we look at the next one as well, the next one is 8. So it's 5 or larger, so this one has to be 3 for a better approximation. And right through here, it is still approximation, but it will be less accurate. So why don't we use a more accurate one if we can? So this is correct. And then B, 2 decimal places, same number. So 0 point after the decimal dot 7, 1. Yes, it is a 1 because the next one is 4. It is 4 or smaller. So then this is 1. Second one is a better approximation than 0.72. Okay. And then number 2, 7/6. So 4 significant figures. So 1 point, this is a figure because 1 carries value. 1.16, the fourth. Okay, the fifth is 6. So this one will be corrected to 7. Okay. As you may have noticed, the calculator also do the auto correction. This should be 1.1666, right? Because, however, this is the maximum digits they can display for this setting. So then it is automatically corrected to 7. Yeah. And then 2 decimal places, 1 point. So we have to keep everything on the left of the decimal dot, of course, and then 1.17. Because the next decimal place will be 6, so then correct the 6 to 7 because this is more accurate. 1.17 is more accurate than 1.16 for the approximation. Number 3, 111 divided by 8. So this is 4 significant figures, 13.88. This one is 5. 5 is the middle, but conventionally we also correct 5 as the larger version of the approximation. So instead of 13.87, we will say 13.88 conventionally. So why 5 is more but not less? So I'm not sure about the reasoning of how this convention is formed. I wasn't there when it is formed. However, for me, one reasonable guess is that when we're measuring something, for example, we're measuring a wooden log, then we're like a carpenter, like cutting wooden pieces. So if we use a ruler to measure how much should we cut off or something, for sawing it down, and then if we get more than the approximation, then it'll be more convenience for later, because if we measure too much, we can still cut off the excess or extra one, right? But if we measure too less of the wood, then the wood may not be useful. Yeah, we have to measure another one, longer one if you measure the one that is too small. So this is like one of my guesses of why if this is 5, then we go to the larger version. Yeah. And then for 2 decimal places, This is also 13.88. Again, this 5 for next decimal places, so we correct it to 8 conventionally. And then number 4, 2 significant figures. So this will be 0.86. Next one is 7. So correct to x6. And then be 1 decimal places, 0.9. Because the next decimal places is 5. Okay. Number 5. 2 significant figures. 8, 2. Because the next one is 8. Be 1 decimal places, 0.8. The next decimal place is 1. So 0.8 is better approximation than 0.9. As you can also may notice, the calculator also automatically corrected the last digit here. It will be like A1, 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 8, right? This 818, then it's corrected to 2. Yeah. So number 6, 5 divided by 12. This is 0.41. How many figures? 2 significant figures for 2. Because the next figure is 6. Be 1 decimal place 0.4. Because the next digit is 1. Okay. And number 7. Correct the following decimal numbers. Okay, so they are all decimals. And then 3 significant figures and nearest integer. So for 3 significant figures, so this is 30.9. The next figure is 4. So then use 9 here. And then be nearest integer. Okay. So for this integer, the integer is the digits is at the left of the decimal dot. So correct to 33 something, and this has to be 1. Okay. So question arises, what if this is 30.95 here? Right? So, actually we will see in question 11. So, okay, let's talk about that in question 11. Then number 8, 2.467. So 3 significant figures. So this is 2.47. The nearest integer is 2. The next digit is 4. So 2 is a better approximation than 3. And then 1.296, 3 significant figures. Oh, so for this one, the 9 will become 0 because it is a 6 here. The 9, if you have to increase it further, it will be 29 will become 30 if you have to increase this digit further. So this will be 1.30. Importantly, we have to keep a 0 as a placeholder to show how accurate is this approximation. This is 3 significant figures. If you only say 1.3, then this is correct to 2 significant figures. Then you'll be like less accurate than we want it to. So this has to be the 0 has to be kept here. And then such that we can see 1, 2, 3 figures, right? And then B, nearest integer. So this will be 1. The 10. three significant figures. So 0 is not a figures, and then 1, 2, 3 significant figures. This is also a figures, although it does not carry value, because it shows how accurate we are. Without the 0, then this is correct to two significant figures. Okay. And then we will misled that this is like less accurate than we intended to. Yeah. So and then the nearest integer. So the integer is the digit at the left of the decimal dot, and it will be 0. Because 0 is closer to this number than 1. So 11. So three significant figures. 1, 2, 3. The first figure is 9, but the next figure is 5. So 9 will be increased. And then to increase 9, we have to look at the next digits as well. So then next digit on the left as well. So then this is 19 has to become 20. Okay. So 19 has to be become 20. Then 220. Keep the decimal dots in place. And then this is three significant figures. 1, 2, 3 significant figures. Okay. And then B, nearest integer, 22. Okay. So this increasing digits thingy also applied if you have a number like this. For example, if you have something like 199.6, okay, and we want to correct it to the three significant figures as well. So it will be, so the third figure is here, 1, 2, 3 figures. The third figure is here. The next is 6. So this has to be increased. To increase this, this has to be increased. To increase this has to be increased. So 199 has to become 200. Okay. It will become 200. That is, 1, 2, 3 significant figures. Yes. So, however, if we, this is correct. This is 3 significant figures. But then this also looks like 1 significant figures because this 20 can be placeholder. We'll see it later. So there's no way around this. So we have to look at the original number, and then to know if this is actually 3 significant figures or just 1 significant figures. Because sometimes the 1 significant figures and the 3 significant figures will be the same, like this. So 12A and 249.56 to that 3 significant figures. So 249. The next figure is 5, so this has to be increased. And so to increase this, then 9 has to increase, then which means 49 has to become 50. And we have 250 has 3 significant figures. And then the nearest integer, so 250 as well. The integer is here. So 5 is larger, so this is 9 becomes 0. Then for 9 to increase, 4 has to become 5. Okay, and then 2 significant figures for larger numbers. This is 3, 8. So we've done our 2 figures. Then the rest will be placeholders. Okay. So you can see this is two significant figures, and which means this could be either from here, this is three, from here to 499.199.6 to here is three significant figures. However, if we want to do one significant figures, it will also be 200. They will look the same. And then B for the there's only two significant figures, and then this is two significant figures, so 3 9, but after the 9, so rough work 3 9. But then the next digit is 6, so this has been increased. So 39 has been increased to 40. So we have 4 0. Then the rest has to be 0 as placeholders. After we finish the two digits, the two significant figures, then the rest will be 0 as a placeholder, such that we know the magnitude of the 4 and this O. This O is carry 1,000 value, and this 4 is carry 40,000 value. So yeah. Oh, then this 0 is does not carry value, but is at the digits of the 1,000. Okay, number 15. Two significant figures. So 2 0. Then the rest will be 0. Okay. Oh, by the way, the rest, what about this 02? Okay, I say 40000. Yeah. Then, no, we don't need to, because this is already enough to show the position. These zeros are only here to show the magnitude of these digits of 4 and 0, and especially the 4. Yeah. So we do not need this. If we do this, then it means we're doing 1 2 3 4 5. Wait, if we do this, it's completely wrong. Yeah. Okay, so then yeah, so this is for the approximation tutorial. See you next video.